Hello everyone and welcome to this video on the Python programming language and machine learning. So today we will be creating a machine learning web app to detect if a person has diabetes or not. Now if you are new to this channel, please click on that subscribe button and that like button. It'll really help out. Now before you begin, you will need Python installed on your computer and you will need to install a few packages. Those packages are pandas, scikit-learn, pillow, and streamlit. I already have those packages installed on this computer here, so I will not be installing it, but make sure that you have those packages installed before attempting to write this program. Now for the development environment that I'm going to be using, it is a IDE called PyCharm, and this is where I will be writing the code. So let's go ahead and get started. So the first thing that I'm going to do is I'm going to come over here to the left and I'm going to right click new and then click on Python file. And this is under my projects folder. And I'm going to call this file web app. So click OK. And now, of course, we have our web app.py file. Okay, so the first thing I'm going to do is put a description in comments about the program. So this program detects if someone has diabetes using machine learning and Python. All right. Next, I'm going to import the libraries that I plan on using throughout this program. So I'm going to import pandas as PD, and then from sklearn.metrics, I'm going to import accuracy score. Next, from sklearn.model selection, I'm going to import train test split, and then from sklearn.ensemble, I'm going to import random forest classifier, and from PIL I'm going to import image, and then last but not least I'm going to import streamlit as st. All right, next I want to create a title and a subtitle for the program or for the web app. So just type st.write, and then you're going to want to put in 3 double quotes, top and bottom, and then a number sign or hash sign, and then type diabetes detection. So this will be the title, and then I'm going to give it a subtitle. So the subtitle will say detect if someone has diabetes using machine learning and Python, exclamation point. All right, next I'm going to open and display an image on the web app. So I'm going to create a variable called image, and I'm going to set it equal to image dot open. All right, and then I'm going to put in the single quotes, and the image that I'm going to use is also in this project folder. So it's right here. It's called diabetes detection web app.png. This is what it looks like. I think it'll be really good on the web app. I think it'll look good, so that's why I'm going to use it. So let's go ahead and go back to the program, and I'm going to right click on the diabetes detection web app file, and then I'm going to copy that file path and come down here and paste it using Control V. So now I have that file path for the image, and I'm going to change the slashes. Okay, so almost done here. All right, so that looks good, and let's come down one line. So now we've opened the image. Now let's display the image. So just type st.image, and we're going to tell it the image that we want to display, which is in the variable called image. And then I'm going to give the image a caption. So I'm going to set caption equal to, I'm just going to put ML, which will be short for machine learning. You can make the caption whatever you want. And then I want to use the column width. So just set use underscore column underscore width equal to true. Okay. Next, let's get the data. So this is the data that we're going to train the model on, the machine learning model on, and we're going to use the random forest classifier for this. Um, the data is right here. It's called diabetes.csv. So let's go ahead and double click that and take a look. Let's scroll all the way up. Okay, so we can see the CSV file, and it has the columns pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, diabetes pedigree function, age, and then outcome. Okay, so outcome will be the target variable. So that tells us if that person or individual has diabetes or not, and that will be shown by the values 0 or 1, 0 indicating that the individual does not have diabetes, and then a 1 indicating that the individual does have diabetes. All right. So the idea is to create this web app where the user can input these values, how many pregnancies have they had, their glucose level, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, and age. And then based off of that input data on the web app, our machine learning model will determine if they have diabetes or not. Okay, so let's go back to the Python file and let's continue getting this data. So I'm gonna create a variable called df and set it equal to pd.read underscore csv, and then I'm gonna put in single quotes. Okay, and then another single quote, and then in that. And let's get the file path of diabetes. So I'm just going to come up here to the file, right click on diabetes.csv, and then click on copy path and come down here and click Control V. Okay. And really what I should have did, I should have chose the relative path, but that's okay. I'm just going to change the slashes here. All right. So this is where the file is located. All right. So now I have the data. I also have the image, so everything looks good. Let's go ahead and let's set a subheader on the web app. So just type st.subheader, and we're going to call it data information. And this will be where we will display the information of the data. All right. So I want to show the data as a table. And in order to do that, just type st.dataframe and then input df. Okay, so now that will display the data that we saw here in the diabetes.csv file. Okay, now I want to show some statistics on the data. So here I'm going to put show statistics on the data, so we can see things like the maximum values, the minimum values, etc. All right, so just type st.write and then input df.describe and then left parentheses, right parentheses, and that should display the statistics on the data. Okay. Next, I want to show the data as a chart. So just type st.bar underscore chart and then input df, and I'm going to set this equal to chart. So I'm going to set chart equal to that. All right. So all that looks good. We have a title, we have a subtitle, we have an image, and now we've displayed the data on this web app. So next thing to do is to split the data into independent X and dependent Y variables. So let's go ahead and let me put that in comments, first. So we're going to split the data into independent X and dependent Y variables. Okay. So X will contain all of the features in the data set. So that's basically all of the columns except for the outcome. And then the Y data set will contain only the outcome columns. Okay, so only the rows in the outcome column. All right, so anyways, we're going to set X equal to df.iloc, and we're going to get all of the rows from column 0 to column 8, and that's not inclusive, right? So it'll be column 0 to 7 is what this will contain, And I'm going to put dot values because I want the array. And then I'm going to set y equal to df.ilock, and I'm going to get all of the rows from the very last column. So that's -1, and then put dot values as well. And that should split the data. All right, so now that I have the dependent and the independent data sets, I want to split those up into training sets and testing sets. So I'm going to split the data set into 75% training and 25% testing. Okay, so I'm gonna create a variable called x underscore train and x underscore test and y underscore train and y underscore test. And I'm gonna set this equal to train test split, and then we're gonna input the independent data set and then the dependent data set, which is y. And then I'm going to set the test size equal to 0.25. So 25% of the data set will be the testing set. And then I'm going to set the random state equal to 0. You can make that any value you want to, really. Random state is used for basically keeping the states of the data. And you can use that later on, but for now we don't need to use it. So you can make that variable any integer value you want. All right. Okay. So now we split the data set into 75% training and 25% testing. Next thing that I want to do is to get the user's input. All right. So let's do that now. I'm going to get the feature input from the user. So this is the person that's inputting the data. Maybe they're inputting it for someone else or for themselves. And it should contain everything from the diabetes.csv file up to the outcome. So all of these columns except for the outcome. That's the data that we need to make this classification on the individual. All right, so let's go back. I'm going to create a function for this. So I'm going to call it get underscore user underscore input. All right. Now let's create some variables. So we need to know the number of pregnancies. And I'm going to set that equal to st.slider. So it's going to be a slide bar that they're going to be using to put in their feature or put in that feature or their feature. So just type st.slider, or is it st.sidebar.slider. Okay. And we're going to call it pregnancies. And the slider will start at the value 0 and it will end at the value 17, and we're going to default it at the value 3. All right, and I have to actually go and look at some of these columns. So let me go to diabetes.csv. What I'm going to do is I'm just going to copy these columns that I plan on using Control C, and then come back to this Python file, and I'm going to use Control V to paste it, and this will make it a little bit easier for me. All right, so the next variable I'm going to use is called glucose, and I'm going to set it equal to a slider as well. So I'm just copying this slider here, and I'm going to paste it right here, and then I'm going to change this to glucose, and I'm going to start it at 0, and then I'm going to end it at 199, and I will default the value at 117. So that looks good. Let's create our next variable, which will be blood pressure. I'm going to put it blood underscore pressure. Okay. And I'm going to set it equal to st.sidebar.slider. All right. And I'm going to change this to blood underscore pressure. And I'm going to start it at 0, and it's going to end at 122. And then I'm going to default the value at 72. And next we have skin thickness. So I'm going to make this a lowercase s, and I'm going to make this underscore and then lowercase t. All right, and let's just paste the sidebar slider there. All right, and then we're going to call this skin underscore thickness, and I'm going to start it at 0, and it's going to end at the value 99, and let's default this at 23. All right, next we have insulin, so I'll make that lowercase. Let's come over here and let's change this here to insulin, and we're going to start insulin at 0. We'll do 0.0, right? Because if I go back to my data here, we can see insulin is, let's see, 1, 2, 3, 4, 5. So let's see, 1, 2, 3, 4, 5. I'm not really sure if insulin uses decimals or not. I just see the value 0 here. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It might not, but we're going to use decimals anyway. So we're going to do 0.02. I'm going to say 846, 846.0. And I'm going to start it at 30.5. Okay. So BMI definitely is a float, has decimal values. So let's make sure that we put that there. So I'm going to set BMI equal to BMI here, and we're going to start it at 0.0, and then it's going to end at 67.1, and we're going to start it or default the value at 32. We'll do 32.0. Okay, and actually for insulin, I'm going to make this 30.0. All right, that looks good. Next variable will be diabetes pedigree function. I'm just going to make this DPF, diabetes pedigree function, and I'm going to set that equal to the sidebar as well. And we're just going to call this DPF. All right. So we're going to set DPF. The starting value will be 0.078 up to 2.42, and I'm going to start it at 0.3725. Alrighty, and then last but not least will be age. Alright, so I'm going to set age equal to st sidebar.slider. We're going to put age here, and we're going to use integer values for age. So I'm just going to start it at 21, and I'm going to end it at 81, and then we will default the value at 29 for the person's age. Okay. All right. So now we've created the sliders for the user's input, and now I want to store, store a dictionary into a variable. Okay, so I'm gonna create a variable called user underscore data, and I'm gonna set it equal to basically a dictionary here. So we're gonna have pregnancies, and it's gonna contain the pregnancies variable, and then we're gonna have glucose. It's going to contain the glucose variable. We have blood underscore pressure. I need to make sure I put those in single quotes. So blood underscore pressure. Okay, and it will contain blood underscore pressure. And we have skin thickness, and it will contain skin underscore thickness. And then insulin, it will contain insulin. BMI, it will contain BMI. DPF will contain DPF. And then last but not least, age, which will contain the age variable. All right. So I think that looks good. I'm just going to move this over for me. And that does it for that variable. Okay. Now I'm going to transform the data into a data frame. So I'm going to create a variable called features because this is all the features that we want for the individual. And I'm going to set it equal to pd.dataframe. And we're going to input user underscore data. Okay, and then we're going to set the index equal to 0. And then we're going to return features. All right, and that should do it for that function. Okay, so now I want to store the user's input into a variable. And I'm going to create a variable that's going to be called user underscore input. And I'm going to set it equal to get underscore user input. So now we can use user input for the we can use user input to display the user's input, right? So speaking of that, let's go ahead and do that now. I want to first set a subheader, and then I want to display the user's input. So just type st.subheader, and we're going to call it user input. So right under it, we will display the user's input. So just type st.write, and we're going to write user underscore input. So now, anytime the user changes these sliders, then we can also see what those values are here, right under the user input subheader on the web app. Okay. Next, let's go ahead and create and train the model. So again, I'm going to be using the random forest classifier. So I'm going to create a variable called random forest classifier, and I'm going to set it equal to random forest classifier. All right. Next, I want to train the random forest classifier. So just type random forest classifier dot fit, and we're going to train it on that x underscore train data and the y underscore train data. Okay, so that's pretty much it. That's how easy it is to create and train a model. And next, we want to show the model's metrics. So like how well did it do? So I'm just going to type st.subheader to create a or to show the model's test accuracy. So here we're just going to put model test accuracy score. All right. So this is where we're going to show the model's metrics, and we have that subheader, just to show that this is where we're going to test the model's accuracy. And let's go ahead and see what that accuracy score is. So just type st.write, and I'm going to cast it to a string. Okay. So here I'm going to put accuracy underscore score, and then we're going to input the y test. So this is what it's testing the model against, which is the y test data set. And let's see if the random forest classifier model can predict the the values in y underscore test given x underscore test data set. All right. And let's see, then I think that looks good. Let's multiply this by 100 to get a percentage. And then let's append a percentage sign here. All right. So hopefully that doesn't give us any errors, but it might. Okay. Next, I want to store the model's predictions in a variable. So I'm going to create a variable called prediction, and I'm going to set it equal to random forest classifier dot predict, and it's going to try to predict and classify if the user's input will be or will show that the person has diabetes or does not have diabetes, right? So it's going to show the outcome based off of the user's input, what it believes the user is, whether it believes the user has diabetes or not. Okay, so I think that looks good. Now let's set a subheader and display the classification. So here we're going to just create a subheader. So just type st.subheader, and I'm going to call it classification, or it's going to say classification. And now we're going to actually display this prediction. So just type st.write and then put prediction. All right, so we can finally see the prediction. And I think that's it. So I'm going to save this file by using the short key Control S. Okay. And then I'm going to open up a command prompt. And in this command prompt, I want to run this program. So I need to know the file location, which I can actually see up here. So in order to run this program, you just type Streamlit and then run, and then put in double quotes. And within those double quotes, we're going to put in the file location. So in this case for me, it's on my C drive, and it's under users, and then under computer science, and then it's in the PyCharm projects folder, and then it's within my project called Python underscore programs, and then the name of the app is web app.py. Okay, so what I'm going to do is I'm going to go ahead and press enter. I'm going to pause the video, and then I'm going to unpause the video when the application starts running. If you do the same thing for your program, the browser should open up for you automatically as well, and then the web app should display. So let's go ahead and give this a try. Okay, so now we can see that the web app opened up for me, and this is what it looks like. It looks pretty good. So we can see the title. It says diabetes detection. Then the subtitle says detect if someone has diabetes using machine learning and Python. Actually, let me see if I can zoom in a little bit. There we go. So again, we can see diabetes detection here in the app. Then we can see detect if someone has diabetes using machine learning and Python. And then we can see this nice image, and then the image caption that is ML, or that says ML, which is short for machine learning again. And then we have our data information. So we can see the data in that CSV file being displayed here in a table. So it looks really, really nice. And then we can see the statistics on the data. So we can see the count, the mean, the standard deviation, the minimum value, the maximum value, and so on. If we come down here, we can see this bar chart on the data. So we can zoom in into each of these individuals, and we can see their age, their BMI, their blood pressure, all color coordinated here. And I'm going to zoom out. All right. Let's go down here. Here we can see what the user's input is. So right now, all these values were defaulted. And we can see how to change those values here. So if I change, let's say, the number of pregnancies from 3 to 17, this will update. And you can see that the number of pregnancies changed to 17 as well here. And then we can also see the model's test accuracy score. So right now, our model is 79.166% accurate on the test data. And right now, it classifies this individual as 0, and the number 0 indicates that the person does not have diabetes. So let's see if we can change that. Let's up their glucose level to 199. Okay, and so now we can see that the model's test accuracy has changed again, and this time they classified this individual as a 1, which tells us that that individual has diabetes. So it classified that individual as having diabetes. And we can change all of these values, of course, and you can see that it's just going to keep updating. But that's basically it. Just like that, you've created a web app, and I think something like this could be very useful to the medical field or to people in general if this right here can be improved upon. So anyways, I hope you all really enjoyed this video. Please leave any questions you have in the comment section. Um, if you enjoyed this video, again, please click that like button and become a subscriber to the channel. And then I want to say a big thanks to all the supporters supporting me on patreon.com. I truly appreciate it. And as always, thank you all for watching, and I will see you all in the next video.